This is the moon. The moon has a mass of 7.3477 times 10 to the 22, or a really large number, or 1.23% of the Earth's mass. It has a radius of 1,737.
Alright, it's recording now.
How long would it take a person to fall off the highest point of the moon? It would take 7 times 10 to the negative 11 multiplied by
Yeah, it's recording now. Holy crap.
How long will it take a person to fall from the highest point of the moon? The highest point is 10,786 meters tall. Insert that into this well-written formula. And one would get equals 115.25 seconds. Compared to Mount Everest, which is 850 meters.
It's not on Earth.
Yeah.
Good. You should tell them that it's on Earth.
Well, well, yeah.
Everest.
So, how heavy would you feel on the moon? The average man would feel 4.73 times 10 to the 14th newtons on his body thanks to gravity on the moon, while on the Earth, that same man would feel 3.82 times 10 to the 18 newtons. So, on the moon, you would experience only 1.23% of your own weight. Okay, stop.
The chemicals in millimeters. The large dark areas on the surface of the moon are called maria, and the maria consists of lava erupted from the inner part of the moon. The lava is called basalt. The lava is called basalt. The flowing molten basalt was not very viscous when it erupted to the surface, and this low viscosity also made it easier to form the crystalline basaltic rock we see today. The pristine form of the non-mere rocks mostly consists of an orthotic gabbro and certain magnesium-rich components. The Lunar basaltic rocks are largely composed of the mineral plagioclase. Plagioclase is a coarse-grained mineral made up of a white, granular aggregate, but water is absent. Minerals are not hydrated on the lunar surface. Now we're going to talk about creep, which is KREEP, and creep stands for potassium, which has its chemical symbol of K, and the rare earth elements, and phosphorus. It is thought that creep comes from deep in the moon's crust and was scattered all over the lunar near side by large impacts. The moon does not have a lot of additional volatile elements compared to the rest of the solar system, such as sulfur, chlorine, selenium, and bromine. But on the other hand, the moon is abundant in the rare earth elements relative to the Earth. Well, remember creep.
The moon is incredibly important to the Earth as it keeps the Earth's tilt angle at a steady 23.5 degrees. Without the moon, the Earth's tilt angle would vary up to 90 degrees and would likely have no life on it like Mars, whose tilt angle is the same as the Earth's but varies more than 45 degrees. The Earth's stable tilt angle keeps the planet's climate stable, as without the stability, the climate would have become incredibly unstable like Mars's, and changed more often that would not allow any organisms to grow on the Earth at all. And all that we see now would not exist today. The moon also has a large effect on the ocean tides. High tide is caused by the moon's gravity pulling at bodies of water that are facing it, or are directly away from the moon on the opposite side of the Earth. The tides generally last about 6 hours and cycle at 12 hours and 25 minutes each time. These tides are what allow creatures living in tide pools to thrive, as the high tide will bring fresh water and food to the tide pools and prevent them from stagnating, while the low tide keeps the tide pools from just being another part of the ocean as the waters separate.